In this static equilibrium problem, we have two supports holding an object up that in the x direction has a force of 600 newtons and in the y direction has a force of 800 newtons. The dimensions to the supports are as listed on this slide. We have three sections: A, or where the force is being applied; B, which is the joint that connects the top support to the wall, which we will be solving for the force on this joint; C, which is the joint that connects the bottom support to the wall, and we will be solving for the force on this joint as well. Looking at this diagram, we can see that the forces are causing a torque in the clockwise direction. In order for these supports to accommodate this load, the upper support, which is point A to point B, will be in a state of tension or being pulled apart, and the bottom support, which is point A to point C, will be in a state of compression or being pressed together. Now, to solve for the force at B and C, we will need to break down this problem into triangles that we can use the rules of similar triangles to find what the x and y force vectors will be. Doing so, for the AB connection, we have a blue triangle with 3 length by 4 height by 5 hypotenuse. The hypotenuse was found by using a squared plus b squared equals c squared, rearranged for solving for c, which is the hypotenuse. This is the Pythagorean theorem. We get the displayed hypotenuse of 5 length using this. The x vector will be going to the left, while the y force will be going down. For the A to C support, we have a triangle that has a length of 3, a height of 6, and a hypotenuse of square root of 45. We use the Pythagorean theorem to find the hypotenuse again. To solve this problem, we must understand in statics problems that the sum of forces equals 0. So the sum of force in the y directions equal 0. We can find the y forces by using the law of similar triangles to find the y force vectors. So the 4 height over 5 hypotenuse times the force at B, which is equal to the by vector, and similarly the 6 height of the orange triangle over the hypotenuse of square root of 45 times the force at C is the C force vector. Now in the y direction, we have a force of 800 newtons going straight down, which will result in a negative force. The 800 newtons will be subtracted from the two y direction forces that were added together, and we will set this all equal to 0 due to no movement. Now, being this is a statics problem, which means there is no movement, the sum of forces in the x direction must also equal 0. So the length of the blue triangle of 3 over the hypotenuse of 5 times the force at B equals the force in the x direction at B. Similarly, the length of the orange triangle of 3 over the hypotenuse of the orange triangle of square root of 45 times the force at C equals the force at C in the x direction. Now in the x direction, we have a force going to the right, which is 600 newtons. This force will be added to the sum of forces in the x direction equation and set equal to 0. Now that we have our equations laid out, let's start solving this problem. First, let's add 800 newtons to both sides of the equation for the y direction formula and subtract 600 newtons from each side of the x direction formula. Now, let's simplify the fractions we are multiplying by the forces into decimal numbers. Doing so, we have the listed decimal quantities. Now we have two unknown variables with two equations. To solve this problem, we'll have to use the rules of systems of equations. Basically, we need to multiply one of the equations by a constant to result in a 0 when added to the other equation. So we see here that if we want to cancel out the 0.8 in front of the force B in the first equation, we must get a constant in front of the force B variable in the second equation equal to negative 0.8. So if we divide negative 0.8 by 0.6, we get that we can multiply the second equation by negative 1.33 to cancel out the force B portion of the equation when added. So now we'll multiply all of the constants in the second equation by negative 1.33. Doing so, we are left with negative 0.8 force B plus negative 0.6 force C being equal to 798 newtons. Now we can add equation 1 to equation 2. We are left with 0.29 force C being equal to 1,598 newtons. Rearranging the formula to solve for force C, we get a force at C of 5,510 newtons. Now to solve for force B, we can plug in force C, what we've just found, into the first equation and solve for force B. Using the rules of algebra, when rearranging the formula, we get a force at B of negative 5,130 newtons. To check our work, we can plug in our force at B and force at C we found into the original equations. We should get close to the same value, but there may be some variance due to the rounding at different stages in this example problem. That concludes this video. Hopefully I've earned a like, share, or subscription. If you enjoyed this video, you may enjoy one of these videos as well. Let me know how I'm doing in the comments down below. Thank you for watching.